Okay, this is the video lesson for Algebra 2 8.1, the reciprocal function family. So in this lesson, we're going to learn to graph reciprocal functions and graph translations of reciprocal functions. So here is our general form of a member of the reciprocal function family, a over x minus h plus k, where x obviously does not equal h because you can't divide by 0. So this function, right, the a over x, this is where it stretches or shrinks or reflects the function, depending on the value of a. And then the 1 over x, right, is shown at the right. This is our parent reciprocal function, 1 over x, where a is 1, h is 0, and k is 0. So that is what that looks like. And these are called branches. Okay, so to graph these, the first thing we're going to do is just use a table. So we'll just pick values of x, plug them into the function, get our values of y, and then plot the points, and then kind of follow the dots. All right, and as we go a lot further in this chapter, we'll do a lot of shortcuts from that. So I'm going to pick some values and put them in as x and then calculate the y's just to save a little bit of time in the video and fill that in. I'll be right back. Okay, so I just started with 0. Obviously, you can't divide by 0, so it's undefined there. And then went 1, 2, 4, 8, just kind of ones that would be easy to calculate, right? 8 without a decimal. And then I did the negative versions. And now you just have to plot them. So we can't plot the first one, but 1, 8, 2, 4, 4, 2, 8, 1, like that. And you can see this is going to go like this. And then we'll do the same with the negative 1, negative 8, negative 2, negative 4, negative 4, negative 2, and negative 8. And it's going to come in like that. Okay, and you can, and I'm just doing a few points just because I know how these go, but you can do a lot more, and you'll see as you plug in these values, like 16, right, you'll get 1/2, so you'll get closer. It's just going to hug 0 here. And same here, as you plug in 1/2, you get 16, and so it's just going to hug these. So that's your graph of that. Okay. So try this one on your own. You pick some values of x that will make it easy to figure out here, and then plot them, and then kind of connect the dots. Okay, press pause to do that, and then check back for the solution. Okay, it looks something like this. You get those values. Okay, and so just here's a concept just of the parent function for reciprocal functions. Right, here's our parent function 1 over x, where x doesn't equal 0. When you change the a, right, the a is going to affect the, it's going to be a stretch if it's greater than 1, the absolute value of that. If it's going to be a shrink if it's between 0 and 1. And then if it's negative, it reflects in the x-axis. Okay, and then the translation, if you subtract h from x, it moves left or right. And then if you add k after the fact, that's your up or down, just like before, same. So we have a vertical asymptote at x equals h and a horizontal asymptote at y equals k. And I'll explain what asymptotes are. And then here's all the transformations combined. So when you have a function like this, each one tells you how everything moves. Okay, so let's just look at an example so I can explain asymptotes and everything. So here this says, what's the graph of 1 over x plus 4 minus 6? So we can see here that a is 1. That means there's no stretch or compression or shrink. H is negative 4, right? We subtract, it's what you're subtracting. And so this means there is a vertical asymptote at x equals negative 4. And what that means, it's basically in a line that the graph hugs but does not touch. So, and that's going to be a vertical line, right? Vertical asymptote, vertical at negative 4. You want to graph that like that. Right, so the asymptotes are a good way to graph these, or a good starting point on how to graph. Okay, and then k is negative 6 right here, and that's your up or down, right? That means the parent function goes down, and that is your horizontal asymptote. So that's y equals negative 6, right? Horizontal lines are y equals a number. So let's go down to negative 6 and draw a horizontal asymptote. So the graph doesn't really cross it. It kind of hugs this line and it just never touches it. Okay, and then it also says to identify the domain and range. So the horizontal asymptote and the vertical asymptote are not on the domain or the range, usually. There are some exceptions, but for what we're doing now, that's true. Okay, so now we just need to plot some more points. And the easiest points, instead of just doing what we did on the last page where we just pick at a bunch of points, the first points we need is x and y intercepts. So what that's going to do is it'll give us a point, basically these branches, you know how there's 2 branches and one in the parent function? we're either going to have a branch up here or a branch down here. We're not going to have both. And we're going to have a branch up here or a branch up here, and we're not going to have both. So if we can figure out where the x and y, if we just have one point here, then we know it goes here, and we don't have it here. So we really just need 2 points. And we also do need to know where it crosses the x and y axis. So the next thing we're going to do is try to find the y-intercept, which is when x equals 0. So just plug in 0 for x. So 1 over 0 plus 4 is just 4. Minus 6, and this is over 1, and then we can multiply these both by 4. So this is 1 minus 24 over 4, which is negative 23 over 4, which is just about 6, but not quite. So this is going to be 0, negative 6-ish, right? So that's my y-intercept. So I'm going to put that, it's just going to be hugging there. It's not quite, so it's above this line. It's going to hug that line, and then we're going to come up over here. It looks like we're going to cross the x-axis somewhere around here. So let's find our x-intercept. That's when y equals 0. So 1 over x plus 4 minus 6. Let's give some more space here. We're going to add 6 to both sides, and then multiply by x plus 4. That equals 1. And then 6x equals negative 23. So x is just about negative 4, but not quite, a little bit less than. So that's going to be right here. And so we can see that's where this graph is going to come and hug there. Okay, so we know that this branch is here. Now we just have to check and see if the branch is here or here. I know it's going to be here because otherwise there would have to be a square in here to keep it up here. But we want to know, we don't know, right? Is there a point here that's going to hug, or is it a point here? So we do need just 1 point down here. So let's plug it. So just pick an x value over here. So let's pick negative 6. That should make it easy. So this is my extra point that we have to find. So let's plug in x is negative 6. Y equals 1 over negative 6 plus 4 minus 6. Over negative 2 minus 12 over 2. This is negative 1. So negative 13 over 2. So this is just about negative 6.5. So here. So it's hugging here. And so we can finish our graph just like that. All right, and that's how you graph these. So it's a little bit of an art, right? But you can follow, right? Figure out what the vertical asymptote is, draw it. Figure out what the horizontal asymptote is, draw it. Find the y-intercept and the x-intercept and fill in the branch. And maybe that'll give you 2 branches. Maybe it just gives you 1, and then find any extra points to show you where the other branch is. Okay, this is stuff. Here is one for you to try on your own. Really try this on your own. Don't just skip ahead to the next. I know it's tedious, but it will really help you. The point of the goal of this is really to just get as much practice as possible. That's how you're most successful. So really practice this, and then check back for the solution. Okay, so it should look something like this, right? You use the vertical asymptote of 2 and horizontal asymptote of 4 to make your dotted lines, and then you find your y and your x intercepts here to make the branch here. Then you need an extra point over here to see where to draw that graph, and it's just there at 4.5. Sorry, it's a little messy in here, but if you want to push pause, you can kind of see where I went with this. Okay, and you can also use Desmos to check. So just plot that into Desmos as a check. But if you're doing that right on a test, you need to show your work so I can see that you know how to get it without the calculator or without the Desmos, but you can check it, use it to check. I actually did on this one because I couldn't get these in the right spot. Anyway, all right, let's move on. Last one, problem 4. This graph is a translation of this graph. What is the equation of the function? So let's see. This graph is going to look something like here. So you can see we're going to follow the vertical and the horizontal asymptotes because the parent function would be right down the middle. So we can see this moved left. Each of these is 2. So 2, 3. So negative 3 is my vertical asymptote. And then, so that means h is negative 3. And then this is 2, 4. This is 4. Y equals 4, so that means k is 4. So this would be 2 over x plus 3 plus 4. So it's a. Okay, so you just use the horizontal and the vertical asymptotes to give you your h and your k, and then you use the a over x minus h plus k as your go-to. So try this one on your own. See if you can come up with the function. This is y equals, right, for this one. And your a is 2. Okay, press pause, try this on your own, and then check back for the solution. Okay, and if you notice that the vertical asymptote was 1 and the horizontal asymptote was -4, then you just plugged in your h and your k, and you had your a as 2. So 2 over x minus 1, all minus 4. And that's it. So time for practice. Enjoy.